So today we are going to look at how to solve some questions in physical chemistry. So we are starting with this question. The question says, what is the expression for Kc for the reversible reaction at equilibrium? So Kc stands for equilibrium constant, and we have a way of writing Kc, that is equilibrium constant. So Kc, for you to write a Kc, it is usually like this. Kc is equal to concentration of product divided by the concentration of reactants. So this bracket is always reflecting concentration. So to measure the Kc, you are now going to take the concentration of product divided by the concentration of the reactant. Therefore, now in this case, our product is fluoride ion and hydroxonium ion. So therefore, our Kc now is going to be the concentration of product, that is the concentration of H3O plus times concentration of fluoride ion, then divided by the concentration of HF times the concentration of water. But ladies and gentlemen, generally whenever you are writing Kc, the concentration of water is usually neglected. So therefore, now the answer will be concentration of H3O plus times concentration of fluoride ion divided by the concentration of HF. So now we are going to look at the objectives that match our answer. So therefore here we can see clearly the answer is option A. So A is the answer. So now let's look at another question. So this is usually how to write equilibrium constant. So whenever you are measuring equilibrium constant, what you do, you take the concentration of the product and then you divide it by the concentration of the reactant. And if there is water molecule in the reaction, then you neglect it. So now let's look at the next question. So here in question 2, the question says, which of these represents the reaction rate for the chemical reaction? So generally, if you want to measure, when we said reaction rates, it means the speed of the reaction. That is, how much of the reactant is converted to product per time, or how much of the product are produced per unit time. So that is why when we are going to measure the rate of the reaction, we have two ways of measuring the rate of the reaction. You can measure the rate of the reaction. You can measure the rates of the reaction. The rate can be measured by either decreasing reactant, by either decreasing reactant concentration with time, or you can also measure the rates of the reaction by increasing products, by increasing the concentration of product with time. So this is a two-way of measuring rate of the reaction. So you can measure the rate of the reaction by decreasing the reactant or increasing the product for unit time. Because generally, if chemical reaction is taking place, of course, before the reaction reach completion, it means that the concentration of the reactant will be decreasing while the concentration of the product will be increasing. So that is why whenever you are measuring the rate of the reaction, you usually see that the rate of the reaction is measured by, if you are using the reactants to measure the rate of the reaction, so it's usually negative for the reactant because it is decreasing while the product is increasing. So that is why we usually use a positive value. So now let's look at the general equation on how to write the rate of the equation. Let's say you have an equation where you have A react with B, and then of course, and this A and B react to produce C plus B. So how do you measure the rate of this reaction? So you can measure the rate of the reaction by either you can measure the rates by one, by decrease in change in concentration of A, so that is why it is negative, divided by change in time. And of course, in this case, we have A molecule. So since we have A, then it's going to be 1. It's going to be 1 all over small a. So the coefficient will be at the denominator. Or still under this, you can use A or you can use B. That is change in B with time, but it's going to be negative, and we have B molecule, so it's going to be 1 all over B. And of course, you can also measure it based on that of the product. So for the product, because it is increasing, so in this case, we are going to use a positive value because the concentration of the product is increasing. So that is why in this case, we are going to have change in C divided by the change in T, and it is going to be positive. And of course, we have C molecule, so we have 1 all over C. Or it can be, maybe you can measure the rate of the reaction by D, that is change in D with time. And of course, you have D molecule, so it's going to be 1 all over D. So you can measure the rate of the reaction by just considering one of the reactant or one of the products with time. So now, let's look at this question and see what will be the answer for this question. And I think you can see clearly here, if we are to measure the concentration of the reactant, it is now going to be the rate. The rate is now going to be just let me learn this. So the rate for this reaction is now going to be, you can measure it by saying rate is equal to 1 all over 2 change in N2O5 divided by the change in time, but it is going to be negative. So do you see this one is in terms of measuring the rate of the reactant, so that is why it is positive. But if we are to measure it in the case of actually measuring the product, and it is now for the product, it is now going to be rate. The rate is now equals to NO2. So the delta change in NO2 with time, the rate of the change in time, but of course the number of molecules here is 4. So it's going to be 1 all over 4. It's going to be 1 all over 4. So the rate of change or the rate of increasing in production of NO2 with time, and of course we have 4, so it's 1 all over 4. So you can now just look at the option and see which of the options suit our answer. So therefore, you can clearly see that the answer here is option C. So C is the answer here. So ladies and gentlemen, if you watch this video and you think that this pattern of solving these questions is okay, then you can actually comment with yes, so that we will send more of the videos. Thank you.